Hello, good morning. My name is Parindaran, son of Ketan Vedan. So today I'm here to explain about the group project for computer architecture. So we are from section 1, and this is my group mates Kukendra, myself Parindaran, and my friend Karthikeyan. So we have formed a group to finish this project. So for the introduction part, uh, we are supposed to use the Littleman computer LMC. So to create and construct a code uh, using the to prove the equation we chose. So first, LMC is a model of a software model for a computer that generally created to teach students uh, the architecture of a computer and learn the machine language. So what does this LMC do? So LMC fetch the instruction from RAM, write and execute simple codes, program machine language. So there are more features of the LMC.
Hello everyone, I am Puketa Narayansamy, Matrix number CE 200 So I will be explaining about the assembly and input using Edelman computer CPU simulator. So this is my equation here. So we have to first submit this language code. We have to run. So first it will ask for input, and I am going to do for C square first. So my input will be 5. So as you can see, it has 5. It has already give the output of 5 square, which is equal to 25. So what has happened here is INP means my input, and STA means it will store the data, and LDA means it will load the data. So when I enter the input 5, it has stored inside C, and I load back C, and I store back inside Z, and I load back Z, which means my C and Z is now equals to 5. So BRZN means branch if 0. If my input is 0, then it will jump to this right here, and it will end this program. Now I am sub with Y, which is 1, and I have already declared here as 1. So once I sub the value of Z with Y, and now I store back inside Z. So now my Z has become 4. So now I am load a new memory, which is ANS, and I add C inside ANS, and I store back inside ANS. So now my ANS is equals to 5, since my value of C is 5. And now I'm using branch, which is it will branch here to the loop 1 here, and it will load back, and I'm load back ANS, and I'm store at 99, and give and out 99 means it will give the output of the box 99 right here. What is happening right here is when I enter the value of C here, which is 5, and the value of Z is also equals to 5, the value of Z is now subtracting with 1. So when the value of Z is moving towards 0, my value of C will be add on with 5. So 5 square is simply means 5 plus 5 plus 5 plus 5 plus 5, which means 5 will add on with 5 times. So that is what happening right here. So once my Z has become 0, the final output of ANS will be stored inside 99, and it will give the output of 99 right here. So next I will be doing for A minus B. So my A will be 6, and my B will be 2. So 6 minus 2, as you can see, 4. It is given the output of A minus B and also C square. It will times the C square and A minus B as in my equation, and it will give the output of the multiplication value of the both input, which is 100. So for the multiplication process, it is actually same as what we did for square method, but here we will be using two input. So one is the output of C square, and another one will be the output of A minus B. So for the output of C square, just now I have stored inside 99, so I have to load back the 99 and I have to sub with y, which is 1, and I store back inside n, so my n has now become 24. And now for the output of the a minus b, so just now I have stored inside g here, so I have to load back g and I store inside h, and I load back h and I store inside 94. So the contents of 94 has become 4, and now I load back n and I check if it is 0 or not. So branch is 0, so if it is 0 it will come here and it will end the program, and it is not 0 obviously. And now I load back h, which is my value of h right here, which is 4, and I load back n, which is 24, and I sub with y, which is 1, and now my n has become 23, and I branch it here. So which means my first iteration of multiplication has been completed. So basically what is happening right here is 25 times 4, which means my 4 is add on by itself 24 times. It means, as you can see here, the contents of h, which is 4, is being added by the contents of 94, which is 4. So this will be add on while the value of n, which is 24, is reduced by 1 until it reaches 0. So the moment it reaches 0, the program will stop and the final output of h will be stored in 97. So now we have settled the numerator. So now we are going to do for the denominator and also division process. So for the denominator, for e plus d, I'm going to enter my input for e as 1 and my d as 4. So you can see we have obtained the output for 1 plus 4 is 5, and the division of 100 over 5 is 20. So what has happened here is the input I have entered 1 I stored as e, and the input I entered for 4 is stored as d, and I load back e and I add the contents of d inside e, and I store in 96 and I output it, so you can display the contents of 96 here. So next, for the division process, I have to load back the data of 97 and also the 96, where the 97 is the output of the numerator just now, where I have output it at 97, I stored it at 97. And next, for the 96 is the output of e plus d just now, which I have stored in 96. So I have to load back those data again, and I have to load 90 and store it as m, because instead of using instead of declaring m as 0, I have to do it in this way, because it is a problem itself in the LMC, so we have to do it in this way. So next, I have to load the data of 97 and I have to check it for 0, and obviously it is not 0 because it is 100, and I sub with the data of 96, and again I store inside 97 and I load back m and I add 1 inside m, so my m is now become 1, and I store back inside m and I branch it. So the first iteration of the division is been completed. So when my contents of 97 become 0, it will output m. So basically the output m is like it is counting the loop, how many loops it has been gone through, and it will output it. And as a final part here, I have used HLT, which will stop executing the program, which means halt, and sub ANS and STANS is for the square program I have used before. I have declared here, and also I have declared all the terms I have used inside my language code as DAT, except for y I have declared is at 1. And that's all from me. Thank you.
Greetings, doctor. My name is Karthikeyan Alanaki Murugu. My metric number is CE200227, and today I want to explain about the explanation of the process. So in this project, our equation is a minus b multiplied with c squared divided with e plus d. So first of all, our first step is square instruction. So our input of the c is 5, so it's stored at c and also stored at z. For step 2, the step 2 is subtraction instruction. So we enter the input of A in our equation as 6 and B as 2. So step 3 is multiplication instruction. So we multiply the value of A minus B and multiply with the value of C. So fourth is the adding. So we add the value of E and D, which is E equals to 1 and D equals to 4. And step 5 is divide the numerator with the denominator. So we should divide the value of A minus B multiply with C and divide with E plus D. We get the final answer by doing that. So that's all from me. Thank you.